Okay, today let's talk about how to design system design of YouTube. So design YouTube. So make it bigger. Okay, first of all, let's talk about the functional requirements. First of all, we should allow users to upload videos. Load videos. And second of all, allow users to watch all different videos from the website. Watch videos of all creators. So other functionality we might don't have time to talk about is that recommendations. And probably the likes, dislikes, comments of videos. So we'll put these two as to do. And we're gonna focusing on the first two. So next is the non-functional requirements. Okay, so first of all, we would like to make sure that it's a highly availability. So of the service. So, and the second rule is that we want low latency when we are streaming, watching the videos. Low latency of videos streaming. So, so also we would like to make sure that whenever no matter the network bandwidth. So the second one and third one is actually something similar that we want to support. So other than that, potentially we might have to be considering some copyright tag and like OCR or like a video AI capability or security kind of stuff. So maybe we'll talk about this if we have time. So for capacity estimation, so we are so sure that YouTube is supporting all different videos, probably in billions of videos and billions of users every day. So actually we we are already sure that we're gonna support large scale. So we could basically skip the capacity estimation until we need to calculate the servers, or it's needed when we're talking about the overall workflow and the diagram. So for the APIs, so we will have two major APIs. One is that we want to post a video and video ID, a name, etc., user, etc. So this is for the number one functional requirements. So number two is a get method that is for watch and video ID equals to da da da. Okay, so let's talk about talk about the overall design workflow. Okay, so first of all, we'll have a user basically, and the user should go over via API gateway. So we could basically utilize the AWS managed API gateway that have capability of load balancing, auth related stuff, and the rate limiting as well. So we don't talk too much about this part, but we use a AWS API gateway to help us manage everything. So the first thing is to have a video service. So video service is basically accepting video upload request. Record metadata. So record the metadata of the request. So it's basically having to be a video database. Okay, so whenever the user is sending a request to the video service that they want to upload a video on their local local desktop or so. So basically, it's gonna return to the user a basically it's gonna give the user a okay, so let me write it down to the DB. Video table. Video ID. Creator. Name. Description. And here's the very important thing is that we need a S3 URL. it, and also some other metadata around the video. So basically, whenever the user is sending request, the video service will like send to the user web like browser of a actually a S3 place that user could start uploading it. So actually, and whenever the metadata placeholder has been created, users start uploading their videos to S3 by actually multiple chunks. So like we could basically open to multiple different ports and make sure it's a parallel uploading to make the upload faster. So parallel uploading ports. Okay, so now we covered the first thing is that we uploaded a video and oops. So the second thing is that we want to have a low latency whenever a user is watching a video. So how does that happen? So basically, we will need to process the video to have chunk them into smaller chunks instead of a entire video format. And also we want to create our videos into multiple different formats and different and supporting different kinds of network. So to support different devices with a different format and different kinds of network of different resolution. So and that's why we need to process the video and transcode our video. So basically what the process is that we will have a CDC over here, which is a Kafka from Kafka. So, okay, so this could be a Flink node that is listened to the offset of a Kafka. So it basically have a have known that a get video metadata from Kafka. Video download from S3, because from the metadata we already know there's a link of S3. And the third one is chunk video into smaller ones. Transcode and make like them differ, make it like various video chunks for different format and different resolution. So send to S3 corresponding location of S3, and the sixth thing would be send it to CDN, content delivery network, if needed. Okay, so in this case, we will need a CDN. Over here. Oops. So it's actually downloading the data from S3, process it, upload back to S3 corresponding location, and it also need to upload to CDN if it's for sure that this video has been popular, or like in general, we want to send it to CDN, and this should be available all across the world. So it should be do this. Or we could have a offline processor. So it's offline analysis service that we could run some algorithm or some computer vision capability that we know this video has to be popular after we do the analysis. Or if we patch the video and see the video metadata saying that this video has a lot of views and a lot of comments, or it's being created via a very popular YouTuber, so we could always have a offline process that takes the video from S3 and ingest into CDN. So this part is a offline and optional process. But however, for the video storage, S3 is always the source of truth compared with the CDN. So we wanted to make sure the Flink is uploading the video to S3 for sure. And like for CDN, it could be asynchronous. So, okay, so basically, the workflow look like this. So user upload the video via video service, and the video service record that database metadata to the database, and the video database is like we could basically partition the video via the video ID. So, or we could even have a partition via, we could actually create multiple different copies for the video database, because if we want to see all the videos from a particular YouTuber, so we could basically use creator ID as the partition key. So like we could have a copy of creator video DB via CDC actually. So partition by creator ID. So because the video over here, we are gonna using the video ID as the partition key. So, and possibly via the creating timestamp as a sort key. Okay, so these two databases we could basically using a MySQL database, and like for sure we could also use a DynamoDB or so, but there's no very strong relations over here. However, like a B tree structure is helpful for us. Like both DynamoDB and MySQL is using B tree structure for the for the indexing. So we could just pick MySQL and use a single leader replication, so that we could accepting writes from the leader, and a couple of read replicas for that, and both synchronized and asynchronous replicas for fault tolerant. So this is a video database, and we are gonna having CDC over here. Data basically flows into Kafka and Flink. So they could be both partitioned via the video ID for sure. So, and the Flink node could basically consume the offset from the Kafka and process it accordingly following these couple of steps until it's sent to S3 and like mark it as completed. So for CDN, if it could be asynchronous. So yeah, so whenever the video has been uploaded to CDN or S3. So from all over the world, we are able to stream it from the CDN edge node. Yeah, and also if like the source of truth for storage is definitely S3. So let me see. Source of truth. And whenever we are streaming from the CDN, and the video is basically slow, and we could always get the video, download the video from S3 as well. I mean, probably to the CDN, and we store it to that CDN edge node, and next time whenever we want to stream from that geolocation, we don't need to have a cache miss again, because we already watched and then we downloaded from S3. So speaking of the video chunk process, it's more like this. So let's say we have a different resolutions, and etc. So also we have a like chunk 1, chunk 2, da, da, da. So this is for different resolutions, and MP4, sorry. And we also want to support all different like file format. And for all different devices, I couldn't list a lot, but just this is what I mean. And overall, like S3. So these are all S3 URLs referencing the location it locates on the S3. Like this. So basically we want the chunking process. We are gonna split into for different resolution for different devices. So like another thing would be the chunk size. So we could basically have decide the chunk size. Let's say we have a chunk of 1 minute and second minute, third minute. So whenever the network is getting slower, and we could always pick up the next resolution. For example, we initially having 1080 chunk loading for this minute. However, we notice the network is getting slower and slower, and for the next minute, we're gonna pick up 360 or so. So that we could accommodate all different kinds of network conditions and don't break the user experience. So when we're choosing the all different chunk size, it's also kind of a trade-off. Could have a like offline analysis over it. So whenever the chunk size is too big versus too small, it basically have pros and cons, because if the chunk size is too big, it's less adaptable to all different kinds of network issues. So however, it's don't need that kind like many management, because from the metadata we're gonna managing all different kinds of chunks potentially. So because I mean possibly the Flink is actually writing back to the video. And the status. So if the chunk size is too small, we will gonna have a lot of data and a lot of metadata to maintain, and it's actually more flexible when we're having all different kinds of network issues. But sometimes if the network is very stable and it could we have to basically send out a lot of data over network for the metadata request. So those are the trade-offs for the chunk size. So let's go back to the requirements. So we talked about the functional requirements when upload videos and watch videos, and we talked about the how to be low latency by making it all different chunks and using CDN as cache, and do some offline analysis to manage the sync of S3 and the CDN. And we also talk about the network bandwidth when we're like, how do we want to load all different kinds of resolutions for different chunks? So also for the availability of, so when we're talking about availability, so it's like, I mean, we don't want our servers to be down. So we basically want replications all over the world. So for example, like it basically could scale as it is, and Kafka and Flink, we could have replications, and it's a fast consuming it from the database, and we have the replicas and the single leader replication for the video database, and S3 is like could be scaling, and we could have multiple different copies across all different availability zones. Yeah, these are all the things that we want to keep the high availability. So, and we also talk about the parallel uploading. Other things that we want to check is probably whenever we are uploading a video. So we want to check if the video is having security issues, not polite issues, or copyright issues when we're uploading a video. And we could basically want analysis for that video for all the AI capability, computer vision related stuff. So these are all the things over here could be handled by some offline analysis tools over here. And if we don't want a certain set of video to be available on the internet, we could always, after analysis, we could always apply the filter, apply permission, apply the permission management over S3, because, okay, overall, we want to be uploaded to S3. However, whatever we want the video to be exposed to the internet, that's things we want to control by applying some certain permission to a particular video on S3. Yeah, that's it for now. Okay, thank you very much.